would you be able to accurately predict from million patients with 2 readings a day? But they're 24 hours. The temperature is changing within those 24 hours. The blood pressure is changing within those 24 hours. Your vital organs are behaving to some extent in a continuous fashion in those 24 hours. Any AI that is being trained on those 2 readings per day is definitely going to fail. But what if in between, you cannot take reading every minute? That's not logistically possible. And there are no methods available that would allow you to do that. And this is the reason it's a new class of objects coming. Now, if you go to a doctor and try to read his mind, doctors would be telling that if the temperature goes up, or if the blood pressure goes up by 2 or 3 points, what would have impact on the lungs, for example? What would have impact on your heart, for example? It means that there is some physics embedded in doctor's head actually that we need to reconstruct and embed into our AI model. And that is to some extent what the machines have already been doing. So what doctors have in their head versus what simulation guys, or what kind of, if you are talking to kind of modelers, mechanical engineer, for example, and they have been dealing with CAD and CAM models, they have been dealing with those models for generations. For them, it's not new. Okay? But the problem starts when you try to bring in that model and embed into your AI system. This is where the problems come. So how can you create models that coexist in terms of both AI functionality and underlying mathematical capabilities of a system? So having said that, digital twins are not new. If you go back to history, so for example, 1985, when people sent their first mission to moon, Apollo, for example, so they were thinking that they had the digital twins. So, but those were to some extent 3D modelings, remote programmers, CNCs, and all those kind of things. So that was the first functional digital twins where you could accurately model the physics of the machine that has to be going into space. Then the second generation digital twins came, probably early 2000, when people started talking about 3D printing, for example. If you are a mechanical engineer, you would create your CAD and COM models and simply give it a press or a command, and 3D printer would simply print that. So this was another type of digital twins, and people from that community started thinking that, by the way, they're also producing digital twins. Then we saw, if you're a civil engineer, for example, here, civil engineering has been doing BIMs, for example, okay, building information models. If you talk to a civil engineer, they would be saying that my BIM is to some extent a digital twins. For example, a whole buildings could be modeled in a computer actually. So you would exactly know what type of windows would be required, what type of pressure it would be applied, and what would be the capacity of the particular room before it's actually physically constructed. So, and then another community came. So around 2016 and 17. So if you are a gaming engine guy, so you are dealing with Unity on Unreal and creating your own games, you are trying to create characters that don't exist actually. Okay, so you can create adversarial games and you could be defender or attacker, but that's to some extent also a visual representation of a battle scenario that people have been trying to emulate in their systems. Another community has been saying that's also digital twin. But there was a problem in all those 4 iterations. Number one, either they were doing only data or they were only doing physics. There was nothing at play. For example, if you ask the games that this is 20,000 records and please learn from them and then train the agents that is behaving or playing in your games, that's not possible. Because that's Unreal and Unity, they have a physics as well to some extent, but that physics is only a simulator for it. You cannot bring these things together. So due to these gaps, a new era is coming where people are trying to bring 3 things together. Number one is data. Most of the talks that you would have heard about large language models and other types of AI, this is to some extent, we are learning from that data. But then another community is in development, that's a scientific machine learning, where they're trying to understand the physics of those machines. Practically anything we see here is a machine. So, and that physics is being embedded in our daily machine learning models. And this is to some extent we are saying is a physics-informed AI, and I will be explaining why we need it. So, by establishing that, so for example, if you are one of the guys working on one of those applications, either for some autonomous robots, for example, or you are dealing with real-time surveillance, probably if you are into sensitive areas, you know that satellites would be the next generation, both in terms of security, tracking, and many other things actually. Or if you are into automated manufacturing or into aerospace, no one would be using LLMs, for example, any of those applications. They are no-go area due to reliability, trust, safety. No one would be using that because LLMs are not building your physics laws. Any of the AIs that has been taught in books would not be applied to these applications. So all that bookish stuff that we have learned so far would become to some extent meaningless. So then why we need to kind of go into the future and start thinking that we need to some extent a different type of AI or different class of algorithms that are better, safe, reliable, robust than what we have seen today. So because we need applications where reliability is a key, where physics laws are governing the behavior of your mathematical, your AI models. So if you are an AI engineer and I ask you that I have produced a result from AI model, and my immediate questions would be, can you mathematically validate the outcome of that AI model? And most, 99% AI engineers said, no, they can't do that. LLMs are black box models. So other day I was talking to another guy who was doing a similar thing. Peter Coveney, he has written a book as well. And he said that in LLMs, you are approximating the behaviors of trillion parameters. And if you are approximating the behaviors of trillion parameters, how can you explain something that each layer you are trying to approximate? So you will not be able to develop reliability, and especially if someone on the plane, kind of aerospace engineer, is relying on the capability of AI models, and you are trying to simply kind of either create a means or trying to approximate. For example, if you are into a plane and there are two situations, 0 or 100, and you have to create a mean, you would be getting something around 50. So it means that approximation would lead to failure. So that's the reasons that current trend would not be applicable to these sensitive applications. Now, so if you talk to kind of modelers or people who are doing simulations, so could be aerospace engineer, could be a climate modeler, for example, or could be a person doing simulations in other areas, high energy physics, for example. So they say that my models are reliable and trustworthy because they could mathematically validate the outcomes of those models. On the other hand, if you talk to a person in industry or academia who is doing AI, they would say that my machine learning could give you high performance, millisecond latencies, and then you could scale up to trillions of parameters. Okay? So you cannot have that with mathematical models, and you cannot have mathematical models that needs performance and scalability. So that's the reality. Where we have to go then? Probably a best solutions could be that we could bring these things together. Okay? So your mathematical models should offer performance and scalability. So mathematical mean it's a partial differential equation, for example. Or your machine learning models should build reliability, trust, explainability, safety, and all others. So safety is a big thing these days in AI. But the problem is people are trying to do safety again with the probabilistic means that are not mathematically governed actually. So if you have to deal with some of those things, so it means that we need to bring the two things together into a single model actually. So And that's the basis that people are developing digital twins, and they are building the foundation of next generation models. So, for example, this is one aspect. So, for example, most of the physics-based system, if you are a mechanical engineers or aerospace engineers or another type of engineers that's doing physics-based system, in physics there's no data actually, because mostly simulation. You could generate data, but by definition, by design, there's no data. Whereas if you are a data engineer dealing with large language models or similar kind of paradigms, so you have a lot of data but no physics. Okay, so and if you are doing a digital twins, you need both physics. The reality is you need some physics and some data. So how can we predict kind of future scenarios when you don't have data or when you don't have physics? So it means that nothing would be reliable. And one of the questions that people are trying to ask is, what is your uncertainty quantification kind of method? So you cannot compute uncertainties if you don't have access to data and physics in the same system. Actually. For example, this is one of the example here. So you are trying to predict a kind of a climate scenario that's in future. So there could be two states. One is coming from your simulations, and another is coming from your data. So you may end up predicting two states, and those are different because they're coming from two different methods. Now, if the both methods are working within the same, to some extent, the physical context within the same models, then you will be able to see that what's the difference between an observed and predicted kind of scenario actually. And then you can, to some extent, calculate the resulting error or uncertainty. And if you could have a high degree of uncertainty quantified, people would be able to trust your models. And to some extent, none of the AI models can give you uncertainty quantification. Another thing is that to achieve that, we need to deal with three types of biases. And some biases are good, some biases we need to introduce actually. So one is observational biases. So another interesting thing is that when you are trying to deal with AI, you assume that your data is gold standard. Your data is coming to be perfect. But in reality, data is not good enough all the time, especially if you're dealing with a medical or in sensitive scenarios. So the number one thing is that you need to deal with the observational or the sensor issues. So assuming that every scanning machine that's doing MMR will be good enough, or every sensor that's collecting the data is good enough, that's to some extent the faulty observation. So number two is the inductive biases, that sometimes we need to guide the models to behave in a certain fashion. Just I gave you an example of a doctor's. So if a doctor is saying that there are 2 readings in between, so doctor could use the physics knowledge of the mathematical knowledge that's embedded in his head to simply govern the behaviors or to some extent change the behavior of the algorithm itself. And the third is to some extent learning bias that people are mostly doing. It's just optimization problems. There are a lot of hyperparameters in non-tune actually. So now you could do that at a theory level. So for example, this is the number one ways people have been doing. If you are doing, for example, simulation in CERN, for example, if you are trying to achieve similar kind of things where you simulate things and then you also learn from the same data and then you try to create uncertainty. So that is the most prevalent methods people have been doing. If you are following, for example, the evolution of machine learning for the last 20, 30 years, so this method has been most common actually. So, for example, a whole science experiments at LHC at CERN, they created the whole machines and they discovered Higgs before the machine was physically constructed. And that's the most complex machine in the entire world, and that's based on the Einstein's theory of relativity. So, and the second area where the people have been kind of making a lot of intervention, and this is the, to some extent, foundation of scientific machine learning, so where you are trying to embed physics equations right in your loss functions or in the learning capabilities of the algorithm. And that's to some extent, especially in sensitive area, for example, NASA and similar big organizations, they're investing heavily and now mostly a scientific community, especially if you are chemistry or physics. For example, this year's Nobel Prize in Physics went to people who were doing similar kind of things. This year's, to some extent, Nobel Prize in Chemistry went up to more or less a similar kind of things. They did not mention the word physics-informed machine learning, but the paradigms and the models to some extent were, to some extent, the integration of mathematical models and the AI. And the third one is essentially active learning, or this is to some extent generative AI. For example, if you ask your LLMs to generate complex equations, or ask the LLMs to generate data that's based on certain equations and then keep on learning. So it's not just the data that's being evolved all the time, it's the mathematics also is being developed as well. So for example, in case of number 2, for example here, you could discuss or derive new type of equations that you didn't know, for example. A lot of mathematicians are trying to use that type of active learning where you give them to some extent a lot of unstructured data and they would be able to use AI to create new type of equations. Or you could solve your mathematical equation using AI because physically that was not possible. And the third is you could remove unrealistic solutions and train the models with a less amount of effort. I will be showing you one of the scenario here in the next slide, for example. Okay, yeah. So this is our recent work, by the way. This is a patent that we submitted recently with British Telecom. And in this particular work, we were trying to bring these things together. So, and we created a separate block that we say is the physics. Our learning function. And I will present two equations. One is to some extent a racing scenario, and train a racing scenario with an LLM, and we train a racing scenario without an LLM as well. Data 10,000 times less data than was required by an existing model. This is the area that I will be discussing. So as and the second issue that we were discussing is we created a whole network digital twin for an entire 6G deployment within a computer. So you could create a whole 6G deployment within a computer, and you could deal with all density issues, capacity issues, portfolio issues, quality of service issues, energy footprint. So
So I will take this opportunity to give you a soft reminder that you have 5 minutes left for your talk out of the 30 minutes assigned to you.
And 5 minutes were.
Yes. So we will give you additional time. Yeah. Okay.
So this is, for example, one of the use cases. So here we are trying to creating a racing scenario when you don't have data, for example. There are simulation models that very compute intensive. You cannot track something in real time. Whereas in other cases, you have a lot of data, but that needs to some extent trillions of parameters. So here, for example, this is a paper that is about to publish in Journal of Machine Learning. So here, we use the model complexity of the existing kind of machine learning models, and we try to invent physics, and our model is 8,000 times less complex actually, because we try to overcome the data issues with physics. So now another project that we have been doing is we have been trying to create a digital twin of the Earth, not obviously entire Earth because there's a big group that's working on. So and within that, we are trying to see, for example, what if a particular kind of crop is grown, for example. So what is the impact of crop on environmental emissions? And probably in Pakistan, you know that 25% of emissions are coming from agricultural kind of outputs or interventions actually. So, and what's the impact then? What type of interventions lead to climate change? Could be floods, for example, droughts, for example. Smoke is one issue. And here you would simulate different scenarios and see that what are the main interventions that you need to do to cut down emissions in a particular scenario. So, for example, here we have been trying to deal with, for example, certain crops can generate more kind of emissions as compared to other crops. For example, here, some of the questions that we are dealing with how a kind of a particular heat wave or 1 or 2 degrees centigrade changes in temperatures could affect the carbon health, and as a result could impact the greenhouse gas balance, for example. And how you could offset the lost income by carbon credits, and obviously what's the impact of different crops on the greenhouse balance. And for example, here in one of the particular scenarios, so by the way, these are the sensors deployed in actual crops. They are trying to measure your NEE. NEE is that how much carbon is being absorbed and how much carbon is being emitted. The difference between the two is NEE. And that is to some extent offer us stochastic differential equations. That to some extent a partial differential equation. You could mathematically model that. So, for example, so we built a machine learning model, and this paper is in the final stage at ICLR, so you will be able to see it next month as well. So, for example, here at the top we have a physics-informed neural networks that we built. The others are obviously state-of-the-art models. We are doing it daily, weekly, monthly, and quarterly projections. So, 3 months ahead, we could project that what would be the impact of particular crop or interventions on the climate models, actually. And you could see that data versus our forecast, we could accurately capture uncertainty. And our models are to some extent 30% more accurate than one of the best models that exist. So, for example, here, these are 3 sites we took actual samples. Now, although on the right side this looks green, but that's a net carbon source. That's not emitting, so absorbing carbon, that's producing carbon. Now, on the left-hand side, you could see that that's a carbon sink actually, because obviously due to biodiversity and other aspects as well. So what we are predicting, we are actually measuring, and we are trying to compute uncertainty as well. Another project that we have been doing is we do this later. So in a way, what's the likelihood that a patient that's admitted to hospital would survive? And what's the likelihood that if we discharge, that will not have a negative impact? We are trying to bring all those data, but most importantly, we are capturing the physics of a lung actually. Lung is a physical machine actually. And then we are trying to predict the kind of outcomes. And we are dealing with 2 diseases, pneumonia and asthma, for example. So based on a certain state of your lung, so you could capture the physics, and based on certain data scans and other things, you could accurately predict or capture that. I will be showing some results, for example, in next slide. So here, we have access to almost 20,000 patients. 20,000 patients that have been admitted at least 3 days in hospitals. And we have been capturing their data for example, for a number of times a day, with the help of different doctors and communities. And here, for example, you could say that we trained the models both on the demographics. So obviously, it should not be overfitted or otherwise. So the previous outcomes, we have X-rays, we have vital signs. And then we were trying to do 2 things. Obviously, within the chest rays and the vital signs, we are bringing in the physics of the lung as well. And we are trying to do the risk mortality and the length of stay. So we were saying that what is the accurate kind of stay a person should be able to either improve, or most likely there would be mortality actually. So, and we did it to some extent for a number of patients, a number of scenarios. And here in the next slide, you can see that so our baseline model starts to some extent in 90% cases, the minimum, we could accurately tell that both the mortality actually, the person would die or survive. And so in both cases, what is the optimum point when the person should be discharged, especially in winter. There are big queues, ambulances on the road because the population is aging, and pneumonia and obviously other kind of respiratory diseases are creating a big havoc. So hospitals would be saving kind of lot of money. And early warning systems or early warning stores is our primary kind of model that we have been trying to train actually. So probably just a couple of more slides and I'm going to finish. So another thing is, this is the project that I was discussing. So we could create a whole British telecom network, especially for 6G deployment within a particular computer actually. So, and then you could not only bring in the physics, because each router has a physics, each switch has a physics. You could deal with the energy modeling. British Telecom is consuming 1% of the total energy. 1% is huge. So the government is asking, yeah, you cannot consume that much energy because that's not sustainable. So then what's the best way to achieve quality of service, energy conservation, and to some extent optimal operations? So you cannot try hundreds of scenarios and then come up with the best one. Rather, you have to do a digital twin so that you could produce one scenario and only that should be the best scenario. So this was another project that we were doing with with Milton Keynes Stadium, for example. So here, can you please press this button because there's a video embedded here. Yeah, it's working. So yeah. So you could see. So maybe you could just. So here, for this particular digital twin, we have developed again with Milton Keynes football stadium. So here you could see that we have tried to model a particular area. That's a different gates within a particular stadium. People are coming from different routes, either through trains, through buses. There are different stops, for example, different signals, and you are saying that which particular gate should be opened and when it should be opened. So, and by the way, the human movement is to some extent a physics behavior. The queuing is a physics behavior as well. The signaling is a physics behavior as well. The crowding is a physics behavior as well. And then bringing the data as well as the physics, so you could accurately you would see that shortly it would be moving into 3D scenario as well. So you could see from different angles that how many people, if for example, on a particular gate or a particular location would trigger a new door or gate being opened, and how that would have impact on your congestion management, for example, as well. Because at the end of the day, you want, so for example, there will be other aspect as well. There will be thousands of cars that will be queued actually. So how can you cut congestion? And the congestion is also a physics behavior, for example. So, and as you would see that it's becoming more and more complex. So we simulated up to 100,000 people, to some extent 50,000 cars, almost 200 trains within 2 hours time span, and obviously almost 50 street lights, signals that are in the region to see that what is the optimum route that you need to follow. So this paper, by the way, the outcome of this paper, this work will be published in soon. So here we are moving from 2D to 3D to just give you a kind of particular scenario. And by the way, this is a long video, so I could present for another hour on this, but I would not like to go into details. So yeah, so here you could have different type of permutations and views to see that in which gate what's the situation. Obviously, you could quantify uncertainty as well. Behind the scenes, by the way, this is a combination of physics-informed neural networks actually. So we have the traditional simulation models and the traditional machine learning models are being integrated, and here to some extent you are getting to some extent almost real-time view how a stadium would be behaving. So this is to some extent so before the match. So before the match, you would see that how many people would be coming, how they would be behaving, where they would be sitting. So where the interventions need to be both into safety, congestions, quality of service, energy, and all those kind of things. And you could plan everything accurately. And then you could create, we say it's resilience planning. What if X fails, or what if Y fails, or what if there is to some extent a kind of lighting issues, or water issues, or rain, for example, or one gate is closed, or another thing. So you could plan all those scenarios here actually. So you could please close that. I'm about to. So
it's
this
a very fascinating simulation, and I'm sure everyone is fascinated by the talk, and they would love to reconnect with you once you're done. So
I'm about to finish. Yes.
About to finish. Okay.
So this is another project that we are doing with CGI. By the way, in next 10 years, all the emissions that are coming from data centers, that would account to 25%. So data centers would become the largest polluters. So this is the project that we are doing. So you could see that CFD, if you're doing CFD, the physics behavior. So that's another project that we have been doing. And the last, I would not be spending, you could read this as well, we are doing it with a fleet of ships to see that how can we could model a kind of what we say swarm behavior, and then what is the physics of the swarm, especially if the number of cars are collaborating, if the number of kind of robots are collaborating, if the number of other devices are collaborating, and how you could transfer the learning to each other. So, and obviously the safety is very important. So this is actually, I wanted to spend a lot of time on this, but I don't have time. So here, you cannot ensure safety of AI without embedding a mathematical physics model into that, because you don't have a ground truth otherwise. So if you could embed AI into a mathematical model, a mathematical model into AI, you would be able to compare and correlate the two things. And most of the safety, by the AI safety, is the #1 research challenge this time. And so the only way to ensure AI safety is the combination of physics and AI working together. So that was my last thing. So in terms of futures, a lot of people are working on bidirectional synchronization. Bidirectional synchronization is that, so on one side is physics, the machine is operating, on the other side is digital twins. How can we create a two-way communications? That digital twin is not learning from the machines, but the machine is also learning from digital twins. The second big area is the quantum digital twins, where, by the way, physics is very compute intensive. To have a real-time digital twins that is offering millisecond latencies, you need to translate or transform the compute intensive cost into quantum accelerators actually. And this is obviously another thing that is a big challenge that as the next direction. And the third thing is that probably you saw that the smart modems or the soft modems, previously everyone had their own physical modems. Now soft modems have to some extent replaced them. So how can digital twins replace or augment part of the hardware functionality that we are seeing in real things? So the machines would become intelligent, and a part of the physical machines would be replaced by digital twins. So that's to some extent the third major things that we are personally exploring and doing in the future as well. I will stop. Probably I don't have the time for questions, but I'm here if you.
Thank you so much, Dr. Anjum. It was absolutely inspiring to see your innovative work. Okay, so our next speaker is Associate Professor Dr. Muhammad Sanusi Azmi from University Technical Malaysia, Malacca UTEM, Malaysia. So Doctor, I will give you a brief introduction about Dr. Muhammad Sanusi. So he is a Malaysian pioneer researcher in identification and verification of digital images of Al-Quran Mushaf. He is also involved in digital Jawi paleography. He contributes to feature extraction domain and proposed novel technique based on geometry features used in digit and Arabic-based handwritten documents. Currently, he's the Dean of the Faculty of Information and Communication Technology at UTEM. actively involved in technical vocational education and training. Additionally, he's involved in research, particularly focusing on graduate employability. Let's all welcome Dr. Mohammed Sanusi Azmi.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you for the chairperson and honorable guests. My name is Mohammed Sanusi bin Azmi. I am from University Technical Malaysia Melaka for the Faculty of Information and Communication Technology. Currently, I am the Dean of the Faculty in ICT. Okay. Today, I want to talk about a pathway to enhance employability and industrial leadership. My research on image processing, but this is the experience of me as a dean of the faculty. So, when we talk about, how to use this one? Okay. University Technical Malaysia Melaka is a university, Malaysia Technical University Network. There are 4 university, focused university. My university is focused on manufacturing and computing. This is the university that is set up to address the need of technical skill in Malaysia, especially for the computing and engineering. And now, when we talk about TVET, Technical Vocational Education Training, sometimes when we talk about this one, there are 2 types of education. One is a normal education that I have been taught during my degree. But nowadays, Industry 1 workers, they can work at the first day of their working day. They is at the first day of work. That is what the industry wants. They do not want to send you to training and so on. They want you already equipped with the technical and with the ability to solve problems and with the ability to use and to write the programming and so on. That is what the industry wants, especially for the developing country. You know, Malaysia, we are a lot of expatriates come to Malaysia and so on, and that also the requirement from the industry is very high. And then, when we talk about TVET, Technical and Vocational Education, we just talk about that one is for the certificate and diploma level. But when the Anton TVET is in 2000, set up by our former Prime Minister Dr. Mahathir, then we have a degree in TVET. Today, this year, our university will lead to set up the program for Master and PhD for TVET. Means that we are moving from the conventional to the practical oriented. When we talk about TVET, first is it must be application oriented. The second one is the assessment. Means that the practical part must be 60% and 70%, and the final assessment is only for 30 to 40% for final assessment. But on the practical part is 60 to 70%. And then TVET, previously TVET is used to move from the poor family to become workers. and to support for the country and so on. But nowadays, TVET is not just for workers, for the poor family, but it's for everybody. And then for our university, each of our program, undergraduate program, it must become with professional certificate. Let's say, I take the Bachelor of Science in Database Technology. So I need to take one certification. That is OCP and OCA and so on. At least one. Means that before graduating, you have your degree and one professional certification in order to make our visible to others. And then, in Malaysia, we have 12 ministries that handle on the TVET. And 12 ministries, and then 12 states with 28 institutions. 12 ministries, we have 670 institutions that handle TVET program. Not only one institution. Also, in the private institution, we have 697 TVET institutions, and total TVET institution in Malaysia is 1,398 TVET institutions. And this is what we get it from here. And this is what we get it from our country reports. So, TVET courses offered in Malaysia from 12 ministries with 1,150 public with 209 programs. For the bachelor degree, we have 209 programs for bachelor degrees. Means that there are a lot of the universities offered the TVET. And then we have diploma. TVET is 1,501, and the certification is we have 3,315. Okay, that is the best of TVET. But compared to the Pakistan, you have more institution TVET and you have more courses offered in the TVET. I checked the website of the Pakistan. It's congratulations. Okay, now you know that is the founder of the Pakistan. Malaysia start TVET 7 years after our independence in 1964. But the founder of Pakistan is Muhammad Ali Jinnah, the honored Muhammad Ali Jinnah. I must emphasize that greater attention should be paid to technical and vocational education. That is what the founder, the view of the founder of Pakistan see. The importance of TVET is very important and relevant. Nowadays, for the country like Malaysia and so on, we are moving to technical vocational education, not only for the certificate and diploma, also for the degree, masters and PhD. Okay, so now you can see the other slide is from the report in 2015. This is I get from the website of Pakistan. 22% youth complete second education, means that the secondary education. And then the best thing about Pakistan, you have one traditional system, is Ustad Shagid system. This is informal. When I look on the YouTube, Facebook and so on, there are many Pakistani, they don't need to have the degree, but they can repay everything perfectly. I can see, and they can repair the car, they can repair many things. That is the best of the Pakistani talents. You don't need a degree, you don't need a certification, but everybody in the world know about Pakistani, about the system of Ustad Shagid system. Is it correct? Yeah. But in order to make you visible, in order to make the expert of the Pakistani, okay, that can repair everything, can repair a car, lorry and so on, if they are in the pipeline of the formal system, they just not only work in Hyderabad, Chiniot, maybe they can work in Malaysia, maybe they can work in France, maybe they can work in United States and so on. Because of, in order to make you visible, you must have a formal certification. That's why TVET is very important. You already have the talent, you have the expert, just to make sure the expert has the formal certification. With this certification, provided by the country or by state, all the Pakistani can go very fast and can be somebody in the world, inshallah. So, for the report on 2015, every year 3.5 million of Pakistani enter to the job markets. That is on 2015. I believe nowadays it can be 4 million. So with 4 million, with the conventional and so on, we must add some value, means that TVET, practical oriented, and then we need to add some value on the professional certification and so on. And the best thing is we need to bring the problem of the industry into our education. That is the most important thing. So that's why in our university we have some subjects, courses, capstone. After 1 year, you need to do single project with the industry project. After second year, you with a group of 5 students, you have to manage and then you do the projects after second year. Then once you pass that subject, then you can do the final year project. And then in our university, in my faculty, is our industrial training internship is in the last semester. You know why? Because of when we put in the middle of semester, we have 2 problems. One problem is while the students go to the industry, they do not want to go back to the university because they already get offered. That is the first one. They want to finish the study. Okay. And the second one, the student want to go to study, but they miss the opportunity to work to that company. That's why we move our industrial training from the we have the 7th semester, from the 6th semester to 7th semester. This is what we did in order to help our students in graduate employability. Now, this is a TVET sector. I get it from this one. Okay, I get it from this website, tvetoreform.org.pk. That is a fact sheet that I download and I study here. Okay, this is the information. Okay, this is some sort of TVET institution that offers certificate and diploma level in Malaysia. It's a public, it's an IKM, Polytechnic, Vocational, Community College, Getmara and EdTech. There are a lot, okay, as I mentioned before, 100. And then this is the 4 Malaysia Technical University that offer bachelor degree on TVET. So our student exam 30%. And then the coursework is 70%. And then the students are very happy because they just focus on hands-on and practical and this one. So, after this one, when we talk about if TVET is good, so what is the proven, what is the evidence that TVET is good? So we get some study from our ministry based on 3,330 TVET graduates from our university, University Technical Malaysia Melaka. So the framework is data resources, data collection and report and analysis from SKPG 2020 data analysis from the Ministry of Higher Education Malaysia. So this is the framework and the flowchart of the graduate employability for U10 workflow process framework. So in this part, okay, we can see here, okay, I don't want to see this one. So we can see this is more detail. Okay, in this more detail, after the student graduated, before the convocation, they want to convo, they must fill in the information about their works and so on. That is what they need to do. That is a framework they need to fill in and so on. But if they are not filling this one, they cannot go to the convocation. They cannot get the certification. So this is compulsory for them. Then we get all the information from the students. So now, for the baseline, okay, that is about baseline from this one. Actually, our government target only 85% graduate employability for each program in Malaysia. 85% only. But since 2021 and 2025, the baseline is 86.7%. However, for University Technical Malaysia Melaka, we get 97.7% graduate employability for all programs. But for the computer science program, it's 98.8%. Actually, you know, I am the dean of the faculty. Every year, we get 11,000 applications for diploma. But we only select 180 for diploma. There are too many one. And then they are from degree program, there are many thousands of students. Okay, apply for the program. But we select only 120 for each program. The some program is 60 students. It depends on the program. And then, from the Faculty of Engineering and so on, they want to move to our faculty and so on. That is the value of computer science nowadays. Computer science, faculty, electronic and computer electronic and so on. The demand is very high. You have the skill, you easily get a job. That is the data. Data from Malaysia shows that the highest is computer science. That is what we want to do. And then, from this one, we can see is graduate for TVET is very high, where GE 2043, the 62.7% are work in the field of computer science. Some they are going for business and others are not going for the business. Going for the computer science and so on. And then this is the confusion. So, that is very significant on the TVET institution in M2. We have proof with data. The TVET means that not necessarily TVET, practical oriented. Do a lot of assignment. Do the project during your study. Will help to increase your visibility. And then, the second one is take as much as professional certificate. They are certificate that you can pay, they are free certificate. Then you just join the certificate. Me, when we want to take new workers, yesterday we conduct an interview. First, we look on the publication for lecturers. Second, because we are the TVET institution, we look on two things. The first one is certification. Do you have the certification? And then the third one is industrial experience. Sometimes we don't look at the industrial experience if you have the certification, not just a degree. If you have the certification, if you are value added to your degree in order to get a job. So it's exceeding national goal and advanced for advanced TVET. Actually, I am not from the TVET education, but what I did is I moved from fundamental to TVET. I proposed an algorithm in the feature extraction. Normally on the research, when we talk about research, we just propose the algorithm and then it's just on the paper. Sometimes happen for the fuzzy logic. Fuzzy logic actually is not very popular. Before, Japan take the fuzzy logic and apply to the machine. for the washing machine and so on. Because European, they are, that time, for the fuzzy logic, there is some taboo. But when Japan takes the technology, the paper from the Lutfizadeh on the fuzzy logic and apply to the machine, for washing machine and so on, the fuzzy logic is become more popular. That's why, in my research, I proposed a new algorithm, and then, this is for fundamental research. Okay, I go for features extraction of orthography. There are a lot of paper. This is example of paper. Okay, and then from there, I develop is Tasheh Mushaf Quran, is automation of Quran Mushaf. Okay, I developed that one. Okay, so I propose a features extraction. And I write all the coding using Java. Okay, and then all those things, I make it a library, and then I ask my student in order to make it as a product, to apply the library, to apply the API, and then, but at the same time, is adding some API, some library into the libraries. So what will happen here is, maybe you can play the video. Is it some video? Okay. No sound, eh? Never mind. I get a pattern from this research. Okay? So this is some example. I developed the algorithm. But after this, when we talk with Antun, we need to come out with something that we can use or something that is a product. Shows that the algorithm is work. In research, we just compare our algorithm with another algorithm with the same data set. If you can prove that your algorithm is better than enough, you can get master and PhD. But for us, it's not stop until you prove that you are better than others, means that we go for apply for the algorithm. Alright, now, okay, this is what I did for desktop application. Okay, and then is from there, actually, what my research is, we can know the Mushaf is written, this copy is copied when, who write that Mushaf, okay, who copied the Mushaf and so on, the date and year and so on. And also, if there are something that is added or less in the text, we can detect that it's not same as the original one. This is the concept of our research. Okay? So, how we do this? I'm not good in Arabic handwriting and so on, but we are using features. Features means something that you can describe objects. something that you can describe object. Good features is something that you can describe object A and object B. That is features. Okay, something that can describe object. So now I move it to webs. I'm using for web, and also I have developed it by using the mobile application. Okay, nearly finished. Thank you. So this is what we did on this one. That's why what we want to explain here is when we talk, we are TVET institution. We need to show that we are not 100% fundamental. We need to come with a product. We must have the engagement with industry, and also we must make sure the content of the curriculum must be 60 to 70% is practical oriented. That's why the TVET institution now, that is the institution that is most people or student wants to go, because they granted the employability, and also you can get the premium salary. In Malaysia, for the degree, premium salary is around 4,500 ringgit. It's equivalent to nearly equivalent to 1,000 USD. This is for undergraduate and for the bachelor degree. For master and level is more higher and so on. That's why with this information, thank you. Assalamualaikum.
Thank you, Dr. Mohammed Sanusi, for that insightful presentation. Your expertise and perspective on technical and vocational education provides clarity and direction for addressing global challenges. So next, we have another speaker. So our next speaker for the session is Dr. Suleiman Shahid from LUMS. Dr. Suleiman Shahid is an accomplished academic and a renowned expert in human-computer interaction and design innovation. He is currently an associate professor of computer science at Lahore University of Management Sciences and the founding director of the LUMS Digital Learning Center at LUMS. He directs the Computer Human Interaction for Inclusion, Well-being and Learning Chisel Lab and manages the university's Usability Lab. Dr. Suleiman is also part of the National Center on the Big Data and Cloud Computing at LUMS. It leads Open Data Pakistan Initiative. Dr. Suleiman's primary area of interest is designing learning and healthcare technologies for the marginal in the Global South, with an emphasis on using participatory and inclusive design to drive innovation. His work focuses on applications for assistive technologies to enhance the quality of life of persons with disabilities and persons with mental health conditions, and learning and playful technologies for children. So I would like to all of you to join me in extending a warm welcome to Dr. Suleiman Shahid.
All good? Okay. Assalamu alaikum everyone. Thank you very much for this detailed warm welcome. Today, I have a very simple agenda, and I'm not going to bore you with the future. I'm going to bore you with the present. And a couple of elephants. So, and that's about computer science education in the era of AI. Something जो हमारे हमारी नींदें सुबह शाम खराब कर रही है. You know, really waking us up that how to deal with this new phenomena in the age of AI. So, as I said, it's nothing fancy, just a couple of reminders in the next 15-20 minutes. So I want to talk about a little bit of the IT sector. I want to talk about HR crisis right now we have. I want to talk about a couple of elephants and hippos in the room. Then AICS education globally, comparing with India. Then how do we have future-ready education framework. Then how LUMS is trying to address this important point through LUMS X. And then a couple of other elephants in the room. So this is a very interesting data which talks about this IT export growth of Pakistan. You will find this data everywhere, in every major WhatsApp group. This data is being shared, and how are we doing? And we're about $3 billion in terms of IT export. There's a lot of big freelancing economy. Just to give you a reference, that Philippines is 10x, and Vietnam is 3x, and also Argentina is about 3-4x. So we are at $3 billion. And the reason we have managed to, I would say, survive, how IT has survived, because thankfully there is no government involvement. It's very difficult to understand for them what we are doing, and we have done a very good job in the early years. There are no physical assets, there's no regulatory body, there are hardly any taxes, there's no local market. Everything we do in the IT sector, we export. So there's no internal issues we have, and there's no age limitation. So some of these things really help us that we're able to get this $3 billion as the export economy. लेकिन जो बुरी बात इसके साथ ये है वो ये है कि a single IT engineer आपका जिसमें है, he or she gets about $40,000 a year in IT exports. So if you want to reach $10 billion, which the government is saying we should be able to do in the next 3 years, and then another one is saying we need to touch $15 billion somehow magically. If you want to do that, so magic is not going to happen without reinvesting on certain things. And if you look at this data, that we have about annual university graduates of 45,000. This number is also disputable. Some people say 20, 25, 28, depending on if you call fintech and all other programs as a part of computer science program or not. But the most alarming thing is that there's a consensus that about 10% or hardly 3,000 are employable. And many of us sitting here, both from academia and industry, know that this is one of the fundamental problems Pakistan is facing right now. You guys are telling us that there are no jobs, and we're telling that there are no right people to find in the market. So this conversation is going on all the time. So that's one important thing to focus on. So finding quality HR is a major hurdle in the IT industry at all levels. And there can be many, many different factors which can play, which contribute to this, but one of the most important factors is also nowadays computer science education, which is quite dramatically bad in tier 2, tier 3 universities. And it's not to blame the university, but the whole framework needs to be adjusted for that. So this is from last year, only 10% IT graduates employable. I don't know how did they get this data, but because they don't count freelancers as a part of the economy. But still, if you add them also, then you can say 25% are employable. So that's a big elephant in the room. But there is also another hippo in the room. And I think you all know that new hippo in the room. And that is this new phenomena of AI. People are saying that AI could replace up to 300 million workers. And there is another report last year, AI advancement could impact up to 40% of all working hours globally, with significant effect on programming and clerical roles. So that's going to be a big impact on the future. So if you look at AI in Pakistan, Pakistan has only 10 to 20%, and that's a very, very important point for all of us to pay attention to, because this is the future we're going to live in, and if we don't address this right now, we'll have a big problem when you guys graduate and when our next generation come in. So 10 to 20% computer science graduate meet industry expectations. Pakistan is still the biggest contributor of low-level technical job tasks in the freelancing economy. AI tools like Copilot, ChatGPT automating 50% of the routine coding tasks, and the dual reality is global innovation and local challenges call for immediate action to redefine education and future of programming in Pakistan. So that's a very critical thing to keep in mind. But we are not alone here. This is also very interesting data which tells us 38% of 2024 batch still waiting placement, and that's Indian Institute of Technology. Indian in IITs. Another very interesting, and that's from 16 October 2024, studied 80% of software engineering must upskill by 2027, and by the time you'll be graduating. So you only have to study, but also have to restudy and reskill yourself. So you have a double responsibility now, right? So you finish your degree, but then you also have to do something else so that you're employable. AI, and that's the Wall Street Journal, and that's also recent. AI is coming out for India's famous tech hubs. And then many of you have been searching now online that shall we go for computer science masters or not? Shall we go for computer science undergrad or not? And all the numbers are booming. At least in our university, we have an unprecedented response on computer science. But is it also alarming or not? I think that's a fundamental question we need to ask. And again, because we love to compare ourselves in India for some interesting reasons, so I thought that's good to see that how India is trying to respond to this. So they have now a very new mechanism through industry policies that they're trying to add new tech jobs by 2028. And these jobs are going to be very high-end jobs and not the very core basic programming jobs. And these jobs are very difficult to create because the university should be ready to prepare students for those kind of jobs. That's I generated through ChatGPT. If Pakistan was at 0 in terms of readiness for employability, India is at 2.373 million. So this graph is also quite interesting to look at. How do we need to respond? So my fundamental message is that without significant reforms, it will be very difficult for us to be part of the global tech economy. And when we talk about $10–15 billion, and even when we talk about employability of the fresh graduates, I think we will have some issues. And I don't belong to the group who just say that internet also came and then industrial revolution came and AI is just going to be another nice tech in our Zambil. I feel about it a little differently, personally. So, future-ready education system. So there are a few things which we have been trying to do at LUMS, specifically, but also as a part of a larger network I'm a part of on CS education and AI education in K-12 as well as higher education. So there are a few things we're trying to do, and I thought I'd share some of those things which we can all follow. And nothing new here, is just that it's a reminder that some of these things we used to do after 5 years, we need to do it on a regular basis, on a yearly basis. So that's a whole difference right now. So two things we've been trying to focus on is active curriculum realignment and going back to the foundation. We all believe that foundation is still the key. So if the critical thinking and the problem solving and again the basics needs to be there. If they are not there, it will be a big problem for us, in the future. And second thing, specifically at LUMS, where we are trying to focus on a lot, is that how to take AI education beyond the computer science. So the complex challenges we want to solve in the future, for that a social scientist needs to understand AI, a business student needs to understand AI, a law student needs to understand AI, education student needs to understand AI. So we're taking it out from the computer science department and we're putting it in the pockets of the much more diverse audience. So I think that's another thing which we feel is critical. Second thing, a few years ago, I was also the founding director of LUMS Learning Institute, and which is working very well now. We started faculty upskilling in a very systematic way. We started diploma programs, we started internal training programs. So we have a whole range of year-long program, similar to the way you do in UK or in Netherlands or in Germany or in USA. So new pedagogies and new awareness of new tools and techniques are being explored. So that's another very, very important point. And if we thought that faculty development training is not important, it'll be very difficult to keep pace with this new reality if we don't pay attention, especially if we don't pay attention to this. Teaching support is also going to be fundamental, especially with increasing numbers. What we have seen here, the TS support is just not going to be ordinary TS support. It needs to be supported by state-of-the-art tools and not only the number of TAs needs to be increased, but also the way they're equipped. So for example, at LUMS, we started a very interesting program which we call Teaching Assistant Professional Development Program. So none of our TAs can start teaching assistantship without taking that course. So it's a mandatory course which we designed. It's an online hybrid course available for all the TAs. So we don't allow any TA to teach and stand in the class anymore without taking that kind of a course. So that's fundamental. Without that, it will be very difficult because you'll have students who will outsmart you and difficult to have the decorum in the class, which requires a very basic understanding how the teaching should be done, especially in programming courses. Thirdly, I talk about this a little bit more, how we are trying to invest on technology-driven infrastructure, on online learning, thinking about hybrid learning environments where both experimentation can happen online, be it physics lab, chemistry lab, biology lab, but also kind of more virtual labs, and taking our experimentation to the cloud also, through subscriptions, through partnerships, and that's something we're also trying to do. So that's our third, tech-driven environment is also very important. Fourth, and I'll talk about it a little bit more also, that how can you be more student-centered and how can you support more hybrid learning approach where students don't come to the classes all the time for everything. So how can you also support them with extended material which they can access post-classroom. So, and this cannot be designed in a ad hoc fashion, it has to be designed in a systematic fashion. At LUMS, we're also trying to do that in a systematic way. I'll talk about it. And then we also started this industrial readiness program. For example, we started a very interesting course in which that course forces interviews by the industry experts. So we had about 55 industry experts visiting LUMS in the last 2 weeks, and they conducted interviews of our graduates so that they're industry ready. So that's another thing where we want to play a role in student-centric learning. And finally, there's a national strategy, one can talk about it. There can be AI strategy, one can talk about it. So I think what university needs to do, and something we tried to do during COVID, but now trying to do it again, is that having a very specialized policy which focuses on the internal needs of the particular university. Because you can have a national policy that will be completely useless when it lands in a very particular university because it has a very specific context. Right? So the bottom-up approach can also be very helpful where you look at your own constraints, you look at your own faculty, you look at your own resources, and just start thinking about it, how such a policy can be crafted and drafted depending on what the needs are. So I think that's also very, very critical. And almost every good university is developing that policy. And you know what? They're trying to change that policy every 3 months because it's not going to be consistent over many, many years. And many months actually now. So, हम इसकी आवाज़ करते हैं. So, as I told you, the last 3 points we're trying to respond to those points through this initiative. इसकी आवाज़ करते हैं.
Members of their community. However, the quality of education in Pakistan is Access to learning is a fundamental human right. When provided equally, high-quality education has a far-reaching social impact, allowing individuals to not only meet their own needs, but also become active members of their community. However, the quality of education in Pakistan is affected by several issues, including but not limited to social class, gender, geographical location, and physical disabilities, creating an imbalance in society that is difficult to address through conventional strategies. That's where we come in. We at LUMSEX believe that technology is a great equalizer. As the next frontier in Pakistan's education, LUMSEX is a digital learning center that aims to realize LUM's vision of learning without borders. No matter who and where you are, whether you're a mid-career professional in Hyderabad looking to evolve in your career, or a university student from Peshawar wanting to fill certain gaps in knowledge, you can benefit from a range of our courses. LUMSEX creates online learning experiences that are contextually relevant, inclusive, and accessible for Pakistan. We create hybrid, asynchronous, and massive open online courses. Our output so far has addressed fundamental gaps in teaching and learning, which will help standardize high-quality education across the country. We aspire to work towards a reality where tens of millions of Pakistani learners can learn anytime, anywhere. Join LUMSEX and help us fulfill our mission to revolutionize digital education. For more information, please visit our website.
Thank you. So, one of the reasons we were trying to build this platform and want to spend more effort on this because through this you can respond to the needs much more quickly. It's much easier, it's a little more less formal to develop courses under a framework like this. And then more importantly, they are more accessible and open to the wider audience. So this is a data science course. I want to give you an example that how we're trying to address a very specific industry gap and how this course can be very helpful. And of course, it's open for many of you. If you can play that.
What you are seeing is a data point. दुनिया ऐसे billions of data points से भरी है, जिन्हें समझ के हम कई important problems solve कर सकते हैं. Data science की fast evolving दुनिया में कुछ key aspects हैं, जैसे कि data को acquire कैसे किया जाता है, इसको clean और visualize कैसे करते हैं, and what are some of the ethical considerations at play. Through this introductory course, you will obtain a holistic understanding of some of these important ideas. In course lessons को समझने के लिए आपको Python की basic understanding चाहिए और mathematics की कुछ foundations की familiarity. To help you learn these tools in data science, हमने इस course में preliminary resources use की हैं. तो अगर आप इस field में शुरुआत ही क्यों ना कर रहे हो, आप इस course को बआसानी complete कर सकते हैं. Upon completion, you will develop foundational expertise and be able to pursue various pathways as a data scientist. ये एक hands-on course है, which will be available to you through our technology partner Ilmex. अगर आपको एक traditional classroom की environment चाहिए, तो ये course एक cohort के तौर पे किया जा सकता है. In this format, you will start and end the course at a scheduled time and get a chance to interact with the subject matter expert during live sessions. इस course के ज़रिए हम LUMS School of Science and Engineering की high quality education और research आप तक पहुंचा रहे हैं. इन lessons में मैं Dr. Ehsan अपने experience से insights आपके साथ share करूंगा. Having worked on projects that have been funded by corporations such as Google and Meta, our goal is to help you become part of a skilled workforce in one of the fastest growing industries in the world. इसलिए अभी कोर्स के लिए साइन अप करें और LUMSEX के.
So that's another course we did. The idea is that we need to respond back and one way could potentially be is very quick online learning, but done very nicely and systematically. Because if you just start making a course without thinking about it, and if you start converting your in-person course to an online course without thinking about it, it's just not going to work. You're not going to watch 1-2 घंटे की class just because it's fun. It's not going to be fun. You have to systematically think about it, and you have to craft an online learning experience, which is very different from an in-person learning experience, and the transition is very difficult to do. But if you do it right, then of course there's a lot of potential for that. So that's how the LUMS and LUMSEX is trying to focus on, and this is a specialization which we are offering. So I already talked about it, and the final thing I talk about, the last two elephants in the last couple of minutes, is that whenever we talk about this education in the era of AI, what we also talk about is that this human AI collaboration, or student AI collaboration, has to be designed in a systematic, planned, and mindful way. And we need to make sure that our students understand that. They, at the age of 16, 17, 18, 19, might not be aware of that. It's our responsibility that has become the part of our daily discourse with them, that how harmful it would be if they start using calculator at the age of grade 1. There's a reason that they grow over time in a more systematic way, and similarly the same approach has to be taken with AI, at least early days, when we're trying to figure out what it's going to do with us. So of course there's a lot of interest now, there's a lot of data which tells that AI can be a great learning partner. It can support you systematically, and I've given only one example, that in the case of programming, this can be a wonderful, wonderful tool, but if we don't do it right, then there are, again, two elephants in the room. First is over-reliance on AI, and second one is AI and cheating. So when we talk about over-reliance on AI, there's a very interesting article a few months ago in Communication of ACM, which talked about this very interesting study also. And they said that we had three groups: one used ChatGPT, one used Parascotama, and one relied on Google, and the third one was able to remember the most, has the best benefits. So we're not saying that GPT is not very helpful, but if you don't use it in a mindful way, its over-reliance on that can have a big impact on retention and learning. So again, as a policy, it has to be a design experience. And the last elephant we have been talking again and again about, if you look at the data, I can also tell you from the data we have from our university, everyone is using it, and everyone's using it in a crazy fashion. There's no system behind it, and people are having fun that I can do the assignment in a second. It's a great thing, it's a great tool, but people are not getting the process right. They're getting the output right. And there's a huge difference between a process and the output. There's a huge difference between an outcome and the way we do things. So what we need to, again, we need to make sure that how can we find opportunity in this great challenge, and how can we move from this output-driven to process-driven evaluation, and how can we, again, have this conversation in our classes on a daily basis, that how we use AI in a mindful way. So through this, I wanted to sort of in summary raise some important points, that we are going to live in the next few years in an era, and we're not aware of how it would look like and how it would behave and how it would react. So we need to be very mindful, and I think the first and the most important thing, it's our responsibility towards our students, that we are very, very attentive to this change. This is our responsibility and commitment to our students, that we make sure that we understand and try to understand how this change is going to impact, and we make sure that they're prepared for the future. We're not aware of how it will look like. So I think this is the conversation I wanted to have, and I'm going to thank you all for your time. And last point is that please don't forget the foundations. That's the most important thing. You can do whatever you want to do, but get the foundations right. Thanks a lot.
Thank you very much, Dr. Salman Shahid. Yes, absolutely on time. So it was a very engaging and enlightening presentation, and it was a privilege to learn from a thought leader like you, especially in this domain of academic education. I sincerely hope we can adopt your advice in our education system. Thank you very much for your contribution. It was a pleasure having you here. Okay. So next we have Dr. Haider Abbas. Dr. Hamad, okay. So our next speaker is Dr. Hamad Naveed from UCP, Pakistan. Dr. Hamad Naveed is an expert in AI and computational biology. His research spans the adoption of AI in the West and its role in enhancing diagnostic capabilities in Pakistan, bridging global trends with local needs. He is currently the Pro-Rector of the University of Central Punjab. He serves as Professor of Computer Science at the Faculty of IT and Computer Science. Dr. Naveed was the founding director of the Computational Biology Research Lab at the National University of Computer and Emerging Sciences, Islamabad, Pakistan. He served as the director of the Lahore campus of FAST from 21 to 23. He received his PhD in bioinformatics from University of Illinois, Chicago in 2012 on a Fulbright scholarship. He was a research assistant professor at the Toyota Technical Institute at Chicago University from 14 to 2017. He has significant training in the Partner Institute for Computational Biology in China and at the COST, Saudi Arabia. Published 60 plus research papers in leading journals and conferences, and won $60 million plus in grant funding. He has co-founded 3 companies to commercialize research. Please join me in welcoming Dr. Hamad. The stage is yours.
Bismillahirrahmanirrahim. Thank you so much for the detailed, warm introduction. Before I actually start, I want to first of all, as the introduction said, all the results presented here have been done at Faisalabad and Lahore campuses. All work was done by FAST students. I'm currently at University of Central Punjab, so hopefully replicating things over there. Before I formally start the talk, Sulman just presented a very pertinent view regarding AI in education. I also serve as the skills committee member at Pasha. So just to correct a couple of numbers while agreeing with everything that he said, because a lot of time we make policies without looking at the numbers, जो बाद में जाके फिर हमें पता चलता है कि क्या हुआ. So currently, according to NSEC numbers, this year 35,000 students are going to graduate in computer science. This is separate from computer engineering and electrical engineering, computer science from Pakistan Engineering Council. So roughly we'll have about 50,000 students graduating, not 25,000. So it's double the amount that we have over here. अच्छा उसके बाद हम और वो जो 10% का नंबर जो स्टेट बैंक कोड करते हैं या पाशा वाले कोड करते हैं उसकी स्टोरी बिल्कुल सेपरेट है. प्लीज डोंट गो बाय 10% नंबर्स. Just to give you numbers, FAST के 5 campuses 4,000 computer science students graduate करेंगे इस साल, तो 3,000 employable हो नहीं सकते. So we have a very good workforce. This is just pointing out because we have to be positive and portray the positive image of Pakistan rather than saying कि हम सब 10% employable produce करें. That's absolutely not true. So just to correct those numbers and agreeing with whatever Sulaiman said, I think just let's start ahead with that. अच्छा जी इसमें I'll again, as Sulaiman was talking about AI, I'll be talking more about AI. But just to put you in perspective, what is the state outside, and I come from a health tech sector, so I'll mostly show you adoption in the health tech sector. Health tech and fintech are 2 of the biggest sectors. Just in the regulations are extreme. So to get something going within these 2 sectors, because of health tech में FDA की regulation, you have to go through clinical trials and get it there. So if something is getting through these 2 sectors, it is going to be adopted everywhere else as well very fast. So with that, I'll just start off with these trends and adoption and then come with what we can do here in Pakistan. I hope there are some kids here. Any one of you recognizes any of these 3 gentlemen? Kisi ka? Okay, so these guys are the ones who won the Nobel Prize in Chemistry just a month ago. And the very significant thing in this is, the first one is David Baker. He won half the prize. He is doing AI, computational protein design. So we can design proteins using AI on a computer. We don't have to wait for experimental biologists to purify proteins, look at what their function is. हम function का सोच के खुद design कर सकते हैं. इस वक्त क्या कर सकते हैं. The second half, the other 2 guys are Demis. I don't know, DeepMind तो जानते होंगे Google का, जो इस वक्त LLM models Google के are coming through this, but they actually designed AlphaMind, which में protein structure prediction की थी using AI. So Nobel Prize की committee that did not sort of had a computer science as a field to give a Nobel Prize in, this year gave a Nobel Prize in chemistry to 3 AI scientists. So this is the impact of AI coming forward. Does anybody know that AI is by Nobel Prize in physics किसको मिला? Again AI को. So that is the impact of AI coming in all the fields, where the Nobel Prize committee, जिसको computer science की समझ भी नहीं थी कि ये एक field है, इस बार basic sciences के अंदर AI को Nobel Prize मिल रहा है. So that's where the field is going. अच्छा, so This is, so I'm going to be presenting Gartner ki report. So Gartner is a company, as I said, it's very hard for hospitals to bring some things in and for AI vendors या कोई भी नए software के vendors to talk to hospitals. जिस तरह पाकिस्तान में इशू होता है कि हम बायोलॉजी और कंप्यूटर साइंस को बहुत जल्दी मैथ और बायोलॉजी को सेपरेट कर देते हैं, almost everywhere this is the same problem. So Gartner, what it does is it talks to hospitals, it talks to healthcare centers, and asks them what their pain points are, what they are looking for, which sort of software do you want to help yourself in everyday operations. Then they go to the vendors and ask them what their capabilities are. आप क्या कर सकते हो? And they try to match, and of course they charge both parties to do that. So when they did this survey in 2022, you can see the adoption LLM ke use cases on the top. Very few of them were actually looking to find or use LLMs in 2022. But going forward in 2024, they came up with this prism where whether you want to adopt AI will depend on your readiness as well, or uske baad feasibility and uski usability. So the top quarter over here, top quadrant is where everything falls into place, or that is where the value is. So just to show you, Emory Healthcare, iska ambient scribe hai, so every doctor in the West has to record all the meeting information. So ambient scribe does that automatically. You don't have to type yourself. You just, there is an automated recording और उसके बाद एक transcript आ जाती है. Very easy use case, already being used in Emory. Similarly, clinician sends messages that you have to, an automated generated message, okay, this is the test that happened, this is your future course of action. Again, all you can do using LLMs, and this is being used at UC San Diego Health. It's already available in market and being used. So it increases efficiency, it increases non-financial value as well. इसी तरह HCA Healthcare के में automated generated clinical documentation कि इसके side effect क्या हो सकते हैं? How do you, two medicines, do they interact with each other or not? This is information already available, you just have to fetch and make it into a report using an LLM. Already in the market, increases efficiency, increases non-financial value. RAD AI, actually, now you can order a radiology key analysis for $50, automated radiology analysis in the West for $50. So no doctor or radiologist is looking at it, an AI model is giving you a diagnosis and it's as good as a radiologist. Orlando Healthcare, if you look at it, this is, you can summarize your electronic health record, you can prioritize workload for the nurses. If you have 100 patients, kisko pehle dekhna hai, the AI can go through the criticality of the patients and tell them these patients you should look at first. Again, increases efficiencies, increases non-financial value. And the list goes on. EHR summarization, automated generated clinical documentation, and all. We also have an $8 nurse available that makes all the tasks. Ab operation theater mein leke jaane hain, ab now taking for radiology. It is by Hippocratic AI, already being used in the West. You are physically replacing people with nurses, automated nurses there. तो इस तरह के आपको clinical decision support systems already deployed at NYU Lagoon के health campus के ऊपर. इसके बाद autonomous clinical coding ये है कि आपके diagnosis हुआ है तो hepatitis का क्या code है exactly उसकी basis के ऊपर आपको पैसे वापस मिलेंगे. So this becomes millions of codes है, doctors के लिए बहुत मुश्किल होता है. So the computer can do that much better. It increases revenue because depending on which code you put, will give you the revenue आपको क्या वापस आ रहा है. Okay. So going ahead, and these are a lot of cases जिसमें आप different hospitals के देख रहे हैं कि क्या आ रहा है. So just to, what I wanted to sort of showcase here is that AI is not a fantasy of something in the future, this is already here. People have already adopted it, and the sooner we get onto the bandwagon, the better it would be, वरना हम बहुत पीछे रह जाएंगे. अब ट्रेडिशनल नेचर पाकिस्तान के हेल्थ केयर सिस्टम की और वेस्ट के क्या फ़र्क है? हमारा बहुत ट्रांजैक्शनल नेचर है. आप किसी डॉक्टर के पास जाते हो, 2000 रुपीस देते हो, nobody cares what happens to the patient afterwards, whether you got better or not. नहीं better होते, you go to somewhere else, give another 2000 rupees. So उसके अंदर कोई quality control कोई नहीं है. There is nothing that you can do for it. But in the West, because of this insurance system, so they make these packages and deals with the hospital systems that in order, we will pay you, let's say $10,000 per patient in a cohort of 1 million, and you have to ensure that the mortality rate is less than 1%, safety of care hai, readmission rate 3% se kam hai, patient experience अच्छा है, time you are catering to them timely. So given these parameters, they give you a fixed amount, 10,000 per patient, and if you manage to do that in 5,000, the hospital saves $5,000 per patient. So they have this intrinsically built mechanism to make the quality of care better and make it in preventing rather than कि कुछ होगा तो बुलाएंगे. तो अगर आप पहले बुला के टेस्ट कर लेंगे, you might be able to prevent a full operation, and that saves the cost for the hospital, not just the patient. So because of that system, AI adoption is higher. आपकी autonomous clinical decision support system में आ रहा है. जबकि पाकिस्तान के अंदर कोई quality को देख ही नहीं रहा, कभी कोई शौकत खानम से पूछ ही नहीं रहा कि आपको mortality rate क्या है. हमें तो यही लगता है शौकत खानम best है. But do we actually know the mortality rate of Shaukat Khanum? The international survival rate in breast cancer is 90%. Pakistan का, मैं शौकत खानम की बात नहीं कर रहा, but कुछ बेहतर नहीं है शौकत खानम का. Pakistan का is 50%. So that is the gap we have over here. On top of that, we actually think that the hospitals are making a ton of money outside, but this is a data that actually from one of the hospital associations that shows that during COVID period, 53% of the hospitals were in loss. So they have to optimize their operations if they have to survive. There's no other option for them. Just like the cost of living and healthcare cost is increasing in Pakistan, the healthcare cost in the US is increasing much more than all other costs. Pakistan में तो inflation 38% एक साल में ही हो जाती है, but उतनी तो वहाँ पे नहीं होती, but still the healthcare cost is increasing, so that's why they need to optimize and bring in this autonomous decision support system. Which is why आप AI adoption बहुत ज़्यादा तेजी से देख रहे हैं. 90% of data science jobs are in hospitals in the US right now. This actually shows you a AI startup market map. This is about 8 months old. You can see in the healthcare system, you can be in the financial sector, can reimburse how much amount is being reimbursed. Are you scheduling the patient rightly? You're communicating with them. Clinical operations ke andar, how much OT is booked, how many beds are there. Corporate ke andar, security, hiring, HR, ye sara kuch. So throughout the cycle, you can see the ones that are in red are all generative AI startups. So a lot of money is going into generative AI health tech. आपको इस वक्त tons of money available होगा वहाँ पे. ठीक है, इसके अंदर नीचे imaging के RAD AI, butterfly, path AI, ये सारे imaging के हैं, बाकी LLMs के ज़्यादातर डील करें. Okay, so what can we actually do in Pakistan? ठीक है, that is what's the perspective in the West. But even in Pakistan, we know that breast cancer is very common. 1 in 8 women in the US will develop breast cancer. We have a similar incidence rate in Pakistan, 1 in 9. If you look at it, if you look at your family size, your immediate family members will be more than 9. So 1 out of 9 women will have breast cancer throughout their life. The issue right now is if you're looking at under the microscope, where you are looking, it can actually determine कि आपका diagnosis सही हुआ है कि नहीं. The microscope के नीचे वो बहुत बड़ी चीज नजर आ रही होती है, but if you are looking on the top right versus top left, you can have a very different diagnosis. So you need a fast and accurate third opinion that can tell you whether the diagnosis is correct or not. So what we started looking at breast cancer histology. This is a biannual conference जिसके अंदर you are given microscopic images and whole slide images, and they ask you to look at where the mitotic nuclei are, या आपका stage of cancer क्या है. So this is an international competition that we started working on. As I said, the cancer burden in Pakistan, this is 2020 का WHO data, very underreported, but even this shows 34,000 patients were diagnosed with breast cancer, only 17,000 survived. International survival rate is 90%, so we are very far behind than the international standards. The issue when you are dealing with pathology images is each of these images more than a GB. So if you try to open 3 images on a traditional laptop, your laptop will hang. जबकि आप machine learning, deep learning की बात कर रहे हो, where you have to show thousands of images. We don't have high performance computing systems. How do you deal with it?
So traditionally what people do is they divide the whole image into segments, small segments इस तरह के, जिसकी वजह से एक region, if you're looking at one region, you actually have no information about the surrounding region. तो एक local information होती है, there is no global information. दूसरी जो issue आती है कि आपका जब data set होता है, most of it is either normal or last stage invasive. दरमियान वाली stage जहाँ पे actually कोई फायदा हो सकता है, कीमो देने से पहले सर्जरी हो सकती है, we don't have enough data. So how do you handle this lopsided, imbalanced data? So no issues. एक तो size of images is huge and you can't look at it together. The other thing is कि there is a huge data imbalance. अगर मैं बगैर data imbalance के इस पे ऊपर machine learning लगाऊंगा, तो वो 75% मुझे normal दे दिया करेगा, 25% invasive. दरमियान वाली दो classes का कभी कोई prediction नहीं आएगी आप. The other issue, as I said, is कि हमारे पास कोई बहुत बड़े GPU systems नहीं हैं. We can't depend on the off-the-shelf AI models that are run on very high-performing computers. So if we have to compete with the West, we have to come with optimized algorithms that work on whatever हमारे पास available है. ठीक है, तो with that intention, we actually ये ImageNet की accuracy है. ImageNet is random pictures, birds, elephants, dogs. और वो चेक कर रहे होते हैं कि different deep learning के algorithms उनमें से कितने % को recognize कर रहे हैं. So here if you look at efficient net का red के अंदर है, इसका B0 model is the smallest model. We started with the smallest model so that we can do it with everyday sort of computers. And we try to see कि हम ये वाला task हल कर सकते हैं कि नहीं. अच्छा, so in this task we had 10 big images, 1 GB से ज़्यादा, and they had asked us to और 4 classes में लेके आनी थी, ठीक है? The one who won that Kovac at all, they won them, they were able to win the challenge. और उनकी accuracy for classification task was 81%. जबकि ResNet जो तकरीबन हर computer science का student सबसे पहला model जो train करता है, that is ResNet, उसकी भी तकरीबन was very reasonable, बहुत करीब थी. ठीक है, efficient net की हमारी थोड़ी सी बेहतर आ रही थी, but actually what it said probably was कि ये काम बहुत मुश्किल नहीं था. It was probably even. But when we delved deeper into it and we asked the algorithm, where were you looking at? Were you looking at the space where the pathology was looking at? So the correlation for the ResNet was less than 2%. The correlation for efficient net was just 11%. Which meant कि local information वो तुक्का तो लग गया था classification का, but you were not looking at the right place, and that meant कि जब भी आप कहीं और देखोगे किसी और data set पे लगाओगे, the performance is not guaranteed. Okay? So what we understood was we had to incorporate somehow the global information. So we made a two-step process. The first one was okay, we were looking at the local patches, and each patch would give me a probability for one of the 4 classes. We would combine that and resize the image into a smaller image to give the global perspective. And just by adding the global information, the correlation, so this is just the correlation, ResNet भी 60% पे आ गया, जो 2% पे था, and efficient went to 70%. So it's actually a very well-known fact that even Western trained pathologists only agree 70% of the time. So this is accuracy of a trained pathologist. ठीक है? And just to show you visual, so the top one is the ground truth, where the invasive part is. If I was just looking at local with ResNet, this is what I get. Efficient net, local, second one. But as soon as I start incorporating the global information, I'm very close to the ground truth in the top. More images. Left one is the ground truth. Middle one is efficient net, just looking at local. And right one is efficient net, local plus global. So this is the smallest model. And just by optimizing how you are dealing with the global and the local information, you are able to match the pathologist, okay, on a bigger image. 1 GB se zyada, you are able to handle all of that. And this was done on GTX 3090. It is, I think, 11 GB ka RAM hai uske andar. It's not a big deal. It's a normal computer system. So this, what I just showed you, was a framework to analyze whole slide histopathology images that integrates local and global context. It generates a probability map along with the resized image to capture the global context. Efficient net B0, जो कि छोटा सा था, was used to generate the local context. We were able to annotate. TCGA is a global atlas. These are not annotated, so we were able to semi-annotate the paths. So this was done by Salman and Maria. Salman went on to do his PhD in Texas A&M, where he left after 6 months to work for Google. He's working for Google from Lahore, sitting here in Lahore. Maria is at Sheffield doing her PhD based on this work. अच्छा ये तो था कि बाहर international data set. Once we were able to do the international data set, we started going to the hospitals asking for their data. So guess what? The real shock was we have never digitized our local data. We don't have a whole slide image scanner to be able to digitize और जिसके ऊपर कोई local काम कर सके. The first thing that we did was to buy a camera-based microscope and we raised the funds from FAST alumni. भीख मांग के पहला माइक्रोस्कोप लिया था. FAST के alumni के लिए तो FAST वाले बैठे हैं तो please a round of applause for the FAST alumni. उसके बाद we were fortunate enough to get a grant from National Center of AI where we got the whole slide image scanner, जिसके we are able to scan and make the first local data set. We now have 320 patients का data set for breast, colon, oral cancer, जिसको हम utilize करते हैं. We made our own annotation portal क्योंकि you can't go to the hospitals again and again के बनाए, so it's a lightweight, किसी भी मोबाइल के ऊपर खोल जाता है and the pathologist can annotate ताकि data मेरे तक आए कि मैंने क्या देखना है. So it's a very lightweight pura mechanism that we have where we are analyzing local data now. अच्छा इसमें when you are classifying the grade of cancer, we started looking in detail के कहाँ पे देखना है. So you have to actually count कितने cells बार-बार duplicate हो रहे हैं. Cancer is nothing but duplication. ठीक है, तो वो count करते हैं pathologists. तो हमने पहला टास्क देखा कि can we automate this counting and can we do it across the whole tissue rather than कि वो छोटी सी जगह पे देखें. So this is actually with sort of focus के attention कहाँ पे दे रहा है. You can see the method is exactly looking on the top of the nucleus. जहाँ जहाँ पे attention ज़्यादा है वहाँ पे मैंने bright वहाँ पे किया है. So the model is able to find the nucleus, mitotic nucleus और वहीं पे देख रहा है और counting proper कर रहा है. It has more than 80% accuracy and it can sort of save more than half the time for pathologists ताकि वो सिर्फ वो चीजें निकाल दें जो सही नहीं लग रही and the rest is taken care of. So this is actually published in Digital Health and the person who did this is currently doing his MS in AI at LUMS. The second thing you going forward, medical के अंदर सबसे बड़ा मसला है availability of your data. Going forward, you'll see a lot of synthetic data. You don't need actual data and there are lots of papers coming out that show that synthetic data combined with a little bit of real data can help you optimize your algorithm. So इसमें what I am showing on the top is actual real mitotic nuclei जो आपको slides के अंदर से निकल रहे हैं और last two rows जो हैं that is used by our own algorithms. हमने synthesized data use किया and this actually helped us optimize our algorithm. Even though they don't look exactly the same, still the performance of the algorithm becomes better once you add synthetic data. Right hand side पे is a slightly different version. उसके अंदर हमारे पास normal के cases usually ज़्यादा होते हैं. So what we did was we copy pasted a few parts. आपको कहीं पे यहाँ पे एक square नजर आ रहा होगा. This is a copy paste from another part. So we actually synthesized data from other data और ना सिर्फ हमने mitotic nuclei को इस तरह cut and paste किया ताकि वो जो आपको border नजर आ रहा है वो border ना learn कर ले. उसमें हमने दूसरे data में भी cut and paste किया ताकि border की चीज निकल जाए. And again this helped us and this one is published in American Medical Informatics Association जो कि कभी मैंने शिकागो में भी publish नहीं कर पाया था वो हमने यहाँ से बैठ के publish किया. Just showing that you have to come up with ways to synthesize data, medical data as well. So going forward, only 5% of the data is going to be real data and 95% data synthesized over generative AI again coming in. We've actually worked on a lot of international challenges. Diabetic foot ulcer के अंदर we were giving a lot of images. This is COVID का time. जिसमें given the images, you are able to you tell them whether the it is infected, amputation होगा या normal है infection. We were in the top 3. Salman again on this. Again COVID के में ये challenge आया था where you were given X-rays from across 200 hospitals and you had to tell whether it was a COVID X-ray normal या pneumonia. We later added TB because हमारे पास TB भी बहुत है इसमें. तो this one again we were second internationally for this as well. All this work was done by a bunch of people, as I said, in Islamabad and Lahore, about more than 25 students. So I would like to acknowledge, हम तो यहाँ पे बातें करते हैं, काम ये लोग करते हैं. For all of them, most of them went for their masters and PhD across McGill, University of Illinois, Sheffield, South Korea, a lot of the places. So, and in the end, I would also like to acknowledge funding support from National Center of AI, National Center of Big Data and Cloud Computing, National Science Foundation of China, Chinese Academy of Sciences, HEC, Planning Commission, and the Fulbright. So thank you so much, Adler.
Thank you very much, Dr. Mohan. It was a very interesting talk, and we are very privileged to have you here and to have your research work shared with us. So please, another round of applause to Dr. Mohan. So if our next speaker is here, Dr. Haider Abbas. Yes, our final speaker for this session is Dr. Haider Abbas, who is a renowned cybersecurity expert from NUCES, Pakistan. He is a leader in shaping cybersecurity initiatives and policies. His work focuses on building a secure digital ecosystem in Pakistan, ensuring a robust defense against cyber threats. So I would like everyone to welcome Dr. Haider Abbas. Today he will present Building a Secure Digital Pakistan Cybersecurity Initiatives and Future Roadmap.
Hello. Yeah. Thank you very much. Bismillahirrahmanirrahim. Let me correct my introduction. The Director General for Pakistan's National Cyber Emergency Response Team at the Government of Pakistan. This is the newly established initiative by the Government of Pakistan that currently I am heading. So I'll be talking about building a secure digital Pakistan, cybersecurity initiatives and the future roadmap. This is actually some of the initiatives that the Government of Pakistan, the National CERT, has taken recently, and how as a student, as a researcher, you can collaborate with the different initiatives that currently we are taking, and how can you be the part of, as a student or maybe as a researcher or as a faculty member, to be the part of these initiatives that I'm going to flash in a few minutes. Points out, Pastor? All right, I'm sorry. So this is my brief introduction. I think it's already been covered by the respected man, and I have been engaged with the NUCES as a professor and head of security at NUCES, and also adjunct with the Florida Institute of Technology and some of the universities around the world. And I have been awarded Tamgai Mumtaz by the Government of Pakistan. So let's start with the good news in the area of cyber security. So Pakistan has been recently ranked as the role model country in the world's canvas. It's in the top tier now. Before this, in the ranking in 2021, 2022, Pakistan was ranked at 79. But now the ITU, the ranking released by the ITU, Pakistan is currently in the top tier. That is the role modeling country in the area of cybersecurity. So there are many initiatives by the National CERT or by the Government of Pakistan that has actually made to this achievement. And you can see many top giants in the list. Malaysia is already there, and some of the other countries you can see in the list. But this is something, should not be misunderstood by all the security measures in all the organization has been deployed. This is just an acknowledgement in the right step that the government or you can say the different organizations in Pakistan, their efforts are in the right direction and there is a long way to go. Yeah, this is something that as an academician or the head of the National CERT, I would like to clear to this statement actually. So the significance of cybersecurity in your world, this has actually happened in Faisalabad 3-4 weeks before, when a motorbike, the battery was actually exploded due to the overcharging, and there were some casualties also, right? So this actually happened in your city, right? 3-4 weeks back. Also, we have seen the Lebanon attacks, where the pagers of the Lebanese militants has been exploded. There are also conspiracies and some of the stories that some of the high-profile assassinations in the world, like the Ismail Hania, and there was also some of the Pegasus virus that actually revealed his location, and it was some kind of heavily used of the artificial intelligence and the latest emerging technologies, as Sahmad was also mentioning. So there are many kind of adversarial AIs, weaponization through AI, and the misuse of AI in the area of cybersecurity, where they are empowering the attackers also to hide their footprints and to actually launch automated cyber attacks on the critical infrastructure of a country. And we have seen these, we have actually investigated many of these kind of attacks in Pakistan also. So, Pakistan actually approved and launched its national cybersecurity policy in 2021. This was a policy that actually explains the way forward, that how Pakistan should respond to the cyber incident, what should be the cybersecurity roadmap for the Pakistan. And as a national CERT, we are actually complier of this policy in various sectors all around Pakistan, starting from academia, from the government sector, from the private sector, even from the strategic organizations in Pakistan also. So this is the broader mandate of National CERT, that's the governance, risk and compliance, capacity building of all the government and private organizations in Pakistan, indigenous technological development in the area of cybersecurity, incident response and cyber incident handling within the country, then coordination with the national and international organizations. We are also in the process of monitoring the dark web and developing some kind of tools here in Pakistan. Then we have some kind of sportive lab that we are establishing in various universities, and today we are also going to sign MOU with FAST that we are going to establish some kind of setup here. So, talking about the specific aspects of national cybersecurity policy, we are actually working, and we have developed a coordinated strategy that is measurable, and that is actually the objectives of various organizations, and we have provided them the guidelines that how they can proceed to deploy or to comply with national cybersecurity policy within their organizations. There were many kind of aspects that were actually discovered during the gap analysis that we performed with the help of different strategic organizations in Pakistan, and it was figured out that the Digital Pakistan initiative by the government of Pakistan, and also the PITB, the NITB, and the KPIT board and other initiatives that is under the umbrella of Digital Pakistan, the main aspect of security by design was actually missing from these specific initiatives that currently we have. And this actually posed many kind of challenges in a vulnerable situation where these initiatives and these solutions that have been deployed and being used in various organizations are being exploited by the attackers from around the world. The main mandate, there are many organizations in Pakistan that are working in the area of cybersecurity and doing a wonderful job. We have the National Center for Cybersecurity, we have the FIA Cybercrime Wings, we have the Army Cyber Command, we have the PTA, we have the NEPRA that is working in the power sector, we have the State Bank of Pakistan that is actually regulating cybersecurity in all the banking sector in Pakistan. Then we have the Air Force that has established this, we have the academia that are working their various research centers, research labs, Pakistan Navy also, SPD. So the main objective of showing this slide is that unfortunately many of these organizations, almost all of these organizations are working in silos. They do not actually collaborate or coordinate with each other, so there could be some kind of comprehensive environment, and one of the mandate of National CERT is to collaborate with these all kind of organization and come up with some kind of coordinated strategy that could be followed by all of the organizations in Pakistan. This will be the three-tier architecture that will be followed soon in Pakistan. Every organization, even this campus, Chiniot-Faisalabad campus of FAST, will be the part of this. They have to deploy their security operations center in their campus, and the feed is going to be given to the HEC at the sectoral level CERT of all the threats that you have. The HEC is going to do some kind of threat analysis or threat intelligence at their level, and then at the national level there will be National CERT that is actually dealing with this. The government has already issued the guidelines and it has reached to the HEC. Probably soon all the campuses in Pakistan will receive this. Similarly, for the banking sector, all the banks in Pakistan, all the branches, they have to deploy their security operation centers there. And the State Bank of Pakistan would be the sector regulator for all the banking sector in Pakistan. Similarly, the PTA for all the telecom sector in Pakistan, NEPRA, all the energy sector in Pakistan, OGRA, all the oil and gas. Similarly, we have like 14 and 15 main sector regulators in Pakistan, and all the organizations. For example, all the private organizations in Pakistan will be under the SCCP, right? Because they are registered with SCCP. So the SCCP would be the sector regulator for that, and all the private organizations in Pakistan will be the part of SCCP, and SCCP would share their threat intelligence with IOCs with the National CERT. We are already in the process of handling the incident and incident management at national level. We are collaborating with various organizations that have already deployed their security operations centers. Even we are monitoring the threat landscape of Pakistan, and you can see that since January 2021, these are the cyber attacks that have been happened on the Pakistan infrastructure. The private sector has been affected 90%, and you can see the public sector 70 of the public sector organization has been affected by these kind of attacks that has happened on the Pakistan's environment. One of other initiative, that is the National CERT Distinguished Trainer Program. Anyone, the expert in the area of cyber security, could join this program. This is available on our website. The objective of this program is that if, for example, we have to do some kind of training for the government sector in Karachi, for example, or maybe in some of the city in Jamshoro, or maybe some of the city in Pashin or Pasni in Balochistan. So there would be some kind of distinguished trainer that will be registered, accredited by the National CERT, and we can actually request that specific trainer to deliver the technical training into that specific area. We have already launched the web and SMS alert services for the threat advisories for all the stakeholders. Even anyone of individual, you can register with this, and this is providing kind of comprehensive guidelines in a threat landscape where how you can handle the specific threat in the context of developing some kind of strategy or some kind of solution for that specific threat. National CERT has also launched the Cyber Wash program. Many distinguished speakers around the world has already joined this initiative. This is a kind of monthly Cyber Wash series, online webinars that are actually actually geared towards the hot issues that has been recently done in Pakistan, and anyone can join this Cyber Watch series as a speaker also. And if some specific organization, say for example, State Bank of Pakistan says that we need some kind of banking data privacy kind of seminar for that, so we can arrange some experts around the world, and it will be delivered through the webinar that we have launched at the national level. Another thing that I realized during my professorship at NUCES, that the research direction of Pakistan is not actually aligned with the research direction that is needed by the government sector or the different organizations. For example, we have many cyber attacks and cyber incidents happening every day in Pakistan. So what we are doing, we are going to dump these all into a database, convert that problems or issues into the actionable research, and this research is going to be given as a direction to the HEC and to the PEC and to all the boards, you can say the secondary, higher secondary boards in Pakistan, that this should be the part of the curriculum, or maybe this should be the areas where the students can do research. So the main objective is that the research being done in different universities in the labs would be for the Pakistan, that will be actually beneficial by different communities living here in our country. Cyber Patriot program is the program launched by the National CERT. If someone has found some kind of vulnerability in Pakistan's infrastructure, in any of the organization, you can report this to National CERT. National CERT will verify that specific vulnerability and guide that specific organization to fix their specific vulnerability. This is not a kind of bug bounty, because we had some kind of legal issues here to launch with some kind of bug bounty program, so we launched this Cyber Patriot program. The person or the organization reporting would be actually credited with some kind of appreciation certificate, and also would be some kind of money that will go to that specific organization as a reward. And that specific organization would be given the guidelines by the National CERT that how you can fix this specific vulnerability through this program. We have also launched the internship program, that is a summer internship program, and also a long-term and the short-term internship programs for the students all around Pakistan. And we are actually signing and collaborating with different universities, establishing our center of excellences, centers there, our regional centers of CERT in that specific universities, and the student can do research that is or internship in the area where the industrial problem will be given to them, and the national problem will be given to them, and they will be working on that specific problem that would be actually beneficial for him. Then there would be a streamlined auditing process. Any organization in Pakistan would have to go through a cyber security auditing and evaluation process. This will be mandatory for all the organizations in Pakistan. By 2028, June 2028, any hardware and software procured in Pakistan should have to go through a screening process by the labs that will be established in Pakistan, and then it will be deployed to actually clean and to actually see if there is some kind of bug devices or the bug software, intentional or unintentional, and after screening that specific process, it will be deployed into the organization. The auditing and evaluation, all the organization has to go yearly through this rigorous cybersecurity auditing, assessment and evaluation process, and this will be a continuous process governed by the National CERT, and we will accredit different labs in Pakistan, different private and public sector organizations in Pakistan that can help the National CERT by deploying the compliance and auditing into the specific organization in Pakistan. We're in the process of establishing forensics and hardware screening lab to counter the supply chain, other kind of threats in Pakistan. This would be also in collaboration with different universities around Pakistan, and we are going to develop these capabilities and tools indigenously in Pakistan, inshallah. National Summit is heavily engaged, and we have the vision of taking industry, academia, and the government on board. We have already signed MOUs and coordination efforts with NUCES, with IBA. LUMS is also in process next week, probably, or maybe after that. It has also been finalized. Then the JICI, IBA, Air University, PTA, NADRA, and all the major organizations in Pakistan will be the part of this consortium. And this will build a kind of comprehensive research ecosystem in Pakistan. National Search Cyber Campus program is the one that is very close to my heart. That is actually, we are actually trying to bridge the gaps between academia, industry, and government by giving them the guidelines and providing them the platform where the problems were fetched from the database that we have developed to transform the issues or the vulnerabilities of Pakistan, giving them into the actionable research. And this Cyber Campus program would be led by the funding by the government of Pakistan, where the students can do their PhD, masters, and even the postdoc research in collaboration with different universities in Pakistan. So as the National CERT, we have a consolidated roadmap at the government level, at an individual level, and at an organizational level. We have specific guidelines or specific strategic planning by establishing the National Vulnerability Assessment Center, conduct the independent audits or the government agencies supporting research and indigenous development in Pakistan, right? We have to ensure the capacity building of law enforcement agencies and to combat the cyber crimes here. Organizational level to help them to come up with their cybersecurity ecosystem in their organizations. Then we have to actually support them with the different kind of incident management advisories and the guidelines for this specific organization, and our role is actually to build their cybersecurity capabilities. At the national level, we would be handling with all the organizations in Pakistan in terms of cybersecurity to empower them and to build a kind of comprehensive infrastructure where we can say that this is going to be a cyber-secure Pakistan. Thank you so very much. Pakistan Zindabad.
Professor Dr. Haider Abbas, for your insightful talk, for sharing your vision for a secure and digital Pakistan. We would all like to give you a big round of applause. Thank you so much. So do we have another speaker? Okay, so we are done. Thank you so much.
Please wait here, we have MOU signing ceremony.
And with that, we conclude plenary session 10, invited talks.
A heartfelt thank you to all our speakers for their invaluable contributions and to our audience for your attention and engagement.
We hope this session has inspired you to explore new ideas and opportunities in your respective fields.
Stay tuned for the parallel technical sessions ahead, and thank you for being a part of this enriching conference experience.
Have a great day, everyone. Have a great day.
ये ऑन है वो सामने देखिए डैश क्यों मेरा भाई मेरा ऑफ हो गया होना ना वजह
I welcome our worthy rector and our worthy director, along with our delegates from Malaysia, Dean of Information and Communication Technology, UTM, and Deputy Vice Chancellor of UTM. I am extremely honored as a student of NUCES that we are going to sign 2 MOUs right now, one with PKCERT and one with UTM. First of all, I would like to welcome our rector and director to the stage. Please, sir.
I would like to call Professor Dr. Zulkifli bin Ibrahim to please come on the stage for MOU. Now, I would like to request Assistant Professor Dr. Mohammed Sunusi Azmi to please come on the stage. UTM and FAST National University of Computer and Emerging Sciences aim to foster collaboration through student and staff exchanges, collaborative research, seminars and training programs in engineering, IT and related fields, alongside initiatives like internships and product establishments. These efforts will be formalized through momentum of understanding. I request the Malaysian delegation to please step forward for a group picture.
जो खींच रहा है वो फोटोग्राफर है आपका ये नीचे जो खड़ा फोटोग्राफर है वैसे ही बना इसको बैठाइएगा जाके अगे खड़ा यार दोनों सिर आ रहे हैं क्लोज किया
I welcome Dr. Haider Abbas, Director General of PK-CERT on the stage. The MOU between PK-CERT and FAST NUCES focuses on cybersecurity through joint research, training, workshop, internships, and skill development, leveraging shared resources to address national needs and industrial demands.
Thank you everyone for joining us.
At around 2:30, exactly at 2 p.m., we have a panel discussion in this curry hall. So be available at that time as well. And then at 3:30, we have closing ceremony of ICIT 2024. Thank you.
कैमरा ऑफ कर दो, लगा